Welcome to Supply Chain Next with your host, Richard Donaldson. Join us as we explore the ongoing evolution of supply chain, from the challenges professionals face every day to the ongoing digital transformation of the entire value network.
Okay, well, welcome to the next episode of Supply Chain Next, and I am ecstatic to have a fellow hitchhiker of the galaxy here in Steven Statler out of San Diego, but you're going to hear a little accent in his voice here, so he's not originally from San Diego, but we'll get to that in a minute, and welcome, Steve.
Richard, it's a pleasure and a privilege to be on your podcast.
Well, the privilege is certainly mine, and honor as well for someone who is a podcaster over 147 or 48 episodes. Been at it for about 6 or 7 years, Mr. Beacon Podcast.
Well, but to get to be on episode 42 is pretty special. We were talking about that. So I got into the whole IoT business via a book that I wrote, which I originally wanted to call The Hitchhiker's Guide to the Beacosystem, as in Beacon Ecosystem. But the publisher, Springer A Press, they were like, no, you're going to call it Beacon Technologies. And so I went along with that. But it's in the subtitle, and I love Douglas Adams. We both do. And so to be on episode 42 is serendipitous and welcome.
And I think if the universe were sending us little signals right now to peer back behind the covers and see how everything's made, this may be that episode where we uncover some of these truths.
Indeed, let's hope so.
So let me just jump right in, Steve, and kind of get into the background. But you obviously haven't always been from San Diego or California, but would love to hear a little bit of the early years of Stephen back in the UK, as I understand it.
Yeah. Well, I was born in San Francisco, but my parents decided that they wanted to live in England. So I grew up effectively British. I got the funny British accent, which has worked out. It gives me kind of 10 extra IQ points in people's perception. And I need every one of those IQ points in people's perception to do what I do. And I run marketing at a company called Wiliot, and we'll get into that later. But it's been a long, winding road from growing up in England and a school system that seems amazingly like Hogwarts when I was like the house captain and the head boy and all that sort of thing. And we had prefects, and it really does seem a bit archaic as I think about it. But I ended up being fascinated by computers. And back in the day, there were no computers in my school, but I got on a train and traveled to the nearest technical college that had a very kind of noisy, big device that shook every time you typed on it, and was very pleased with myself carrying green bar paper printouts of programs that didn't do very much. But
and this was just to put some time frame around. This was kind of the early 80s, right? Yeah,
so it was actually the 70s. Okay. And then I got
not to date everybody, but there's a reason for the question, because contextually, I think it lines up against some of the things that you've done, but that's why I wanted to kind of get that in there, is that you were right at the very forefront of the kind of beginning of messaging that was happening.
That's right. So I was fortunate. I had a misspent youth. I flunked and didn't go to any of the universities I wanted to go to. I went to a technical college, which ended up having an amazing computer science program. And I had seen 2001: A Space Odyssey, was awed by the character of Hal. I wanted to build Hal. And so I did this computer science degree and ended up working for a string of wonderful companies doing some interesting consulting work in the early days, research into OCR. Ended up at a company called Sequent Computers that latterly became part of IBM, and they pioneered open systems and multi-processor computers, putting lots of cheap microprocessors in to sort of dethrone the mainframe. That was our thing. And we became the platform that Oracle kind of got its momentum on, because we had lots of cheap processing power. And I learned a huge amount in over 14 years of solution selling, systems architecture. And because the UK operations of Sequent did pretty well. A lot of us got transplanted to Oregon, which is where the headquarters was of Sequent. It was originally kind of a spin out from Intel, a lot of senior Intel execs. And so got to kind of my homing instinct back to America kicked in. And after IBM bought Sequent, we went from a 3,000 person company to a 300,000 person company. And the dot-com boom was booming. And it was clear that whilst it was a privilege to be at IBM, I learned a lot in the year that I was there. There were other opportunities to get involved in this internet thing, and a bunch of ex-colleagues started a company over in the UK called Volantis that pioneered the wireless web. And when I was at IBM, one of my last acts was to make a kind of big bet on this thing called WAP, which was Wireless Access Protocol. And I thought, these phones, there's going to be more than just phone calls on these phones. And I was lucky it turned out to be the case. And so Volantis was jumping on that, and they needed someone to set up their US operations. And I'd worked with the Brits that were at the core at Volantis. And so I spent some very happy years. It was a bit of a roller coaster. The dot-com bust happened. I'd set up a whole organization, which I had to lay off. And I ended up working for nothing for Volantis, basically commission-only sales. And after a year of selling nothing, and my wife kind of looking at me in a very worried way, 2 young kids who we were kind of concerned about health insurance, I managed to close a deal with Vodafone, the largest telco in the world at the time, and made more money than I'd ever made in my life. And Volantis said, "You're going back on a salary. This is not a good deal for us." So after that, I worked with them for years and slowly got to sell this wireless software to nearly all of the carriers in North America. So the 3 of the top 4. The only one I didn't successfully sell to was Verizon. And so I was advised by them that if you want to get into us, you need to get in via Qualcomm. So I started flying down to San Diego and working on this relationship with Qualcomm. And I actually wanted Qualcomm to buy Volantis because they were such a cool company, great culture, very similar to the one that had been at Sequent, where people were treated well and innovation and technology was respected. But that didn't happen. But they did offer me a job. And since they weren't going to buy the company I worked at, and things were going a little pear-shaped at Volantis, after initially saying no, I said yes and moved our family down from Oregon to San Diego. And it was one of the toughest things we'd ever done. My wife was in tears when we were doing the trip around sightseeing San Diego, not because it was horrible, but because it was so nice. She knew there was no way that we would say no. So Qualcomm made it easy. My wife was very understanding, and now it turns out that she loves it because San Diego is a pretty beautiful place. So I ended up working at Qualcomm, and initially was trying to get them into the music business. They wanted to go from powering app stores, which they did way before Apple had an app store. They were paying out billions of dollars to people that wrote solitaire and Sudoku apps that were sold on feature phones back in the day. And they were the app store that powered Verizon and 60 other carriers. So it was a huge app store business that evaporated once they helped invent the smartphone, which they did. And anyway, my career at Qualcomm was educational, biggest mobile semiconductor company in the world. But I was looking for something that would be, I don't know, a bit more creative than the role I was in. And so I entered a competition which was called Venture Fest, where you had to come up with ideas. And my idea was Qualcomm should get into the retail vertical, because what's the one thing we all do every day? It's shop, So if you want to get mobile technology in people's hands, focus on retailers and retail, and it includes everything from vending machines to quick service restaurants and convenience stores, which, like it or not, we tend to go to a lot. And fortunately, I found a a rich friend of the CEO at the time, Paul Jacobs' best friend, Rocco Fabiano, and he agreed that it was a good idea. And so I got to be his strategy guy, and we created Qualcomm Retail. And Qualcomm Retail did a bunch of stuff. But one of the things that they did was to jump on the idea of Bluetooth being used for more than audio, for the creation of something called a Bluetooth beacon. And then, we'd had that idea, and there was a very talented group that coalesced around that, and that spearheaded that idea. And then Apple came out with the iBeacon just at the time we were doing this, and that kind of threw gasoline onto the Bluetooth beacon fire. It
so
took
let me
off.
Pause in for 1 quick sec, Steve. So because
Yes.
you are a masterful storyteller. I was gripped. I'm sitting here going, okay, and I don't want to get too because you're gonna get right into the how Bluetooth, or how we took a technology that had a particular, 30-foot wireless kind of radius or whatever it is, right? Kind of my personal, back then, I think it was a PAN, personal area network was the whole acronym, right? Way back in the day. But before we get into that, you started in a technology kind of course. You wanted to build HAL, which probably means you wanted to build Marvin from Hitchhiker's Guide, right? And like a lot of us, we were kind of tinkerers back in the day, but you found your way, as I'm looking through this, weaving into more marketing, strategic, I think you can play technologist, but I'm not sure you would portray yourself as a hardcore technologist, CTO type. You're actually more of a technology kind of, strategic look, at things. You see how things go together. And there's a 2-part question here. One, was that just a natural evolution of kind of you, right? Because I can kind of see that in your characteristics, your personality, that comes through. Again, storytelling is fundamental to really, quite frankly, strategy to some extent, right? If you can't tell a good story, I don't know how you can do strategy very well, right? Or at least convey strategy. You can think it, but you'll never get it executed. With that said, though, a lot of storytellers who tell a good story, have a beginning, a middle, and an end. Well, in that way, they're already thinking strategically. They're kind of connecting dots. They're putting things together. So one, I was asking a little bit about that progression and just your own reflection on that, and how it led you to more of a strategic role. But then two, and I'm going to double click on this one, you're also at a fascinating time to be at Qualcomm, right? Here's a giant company that was in this all microprocessor thing. And they kind of went through, in the period that I'm looking at, kind of a lot of evolution during those 6, 7, 8 years, right? To where now all of a sudden, they've come on the other side of that. And I think Qualcomm today, without reservation, almost owns the kind of microprocessor, kind of mobile device chip market. In Intel and NVIDIA, they can go beat each other up for the big processors, right? The x86s and whatever, but anything that's underneath that at a microprocessor level, Qualcomm is just dominated, right? But that wasn't the case when you landed there. You were there right when it was kind of morphing, and they tried a bunch of different things, right? So 2 parts. One, question about you and your own reflection in your path to getting to this more strategic marketing role, and how you started in more hardcore tech and kind of evolved. And then 2, a little bit into the Qualcomm story, because you were there at a really fascinating time where the company kind of molted itself a little bit, right? It sort of went full circle. It kind of came for processors, explored a bunch of different things, ended up back in microprocessors, dominated ever since, right? And some of your thoughts on that as well.
Yeah, it's an interesting question about why you ended up being the way you are. And to me, I think there's like 2 bookends to my interests and character. On one hand, I love technology and the details. On the other hand, I really love the big picture. And so trying to kind of schizophrenically join those 2 bookends up can be destructive, or it can be creative. And for me, when I left I went to a polytechnic, so not even technically a university, but got a great computer science degree. And I went to Logica, which was it was a very prestigious consulting organization. I was kind of lucky to get in because they generally recruited from Oxford and Cambridge. But I joined, so sort of turned up expecting to do a bunch of technical work, apply my compiler writing, operating system knowledge, networking knowledge. And they said, no, you're going to be in sales because you see those people over there, and there's kind of a crowd of very autistic-like geniuses doing the technical stuff.
Right.
And they're like, no, you're going to talk to customers. And I'm like, great. And by the way, you get a company car. I'm driving London. I'm 20. I have a new car. Life is good. But after a year or two of that, on one hand, I loved it. But on the other hand, it's like no one who's my age is doing this. They're all writing software. I want to do that. And so I literally said, I don't want the car anymore. Give me a programming job. So I went back into that. And I ended up loving it and wrote the internals of operating system internals, Unix, it would be called Linux now, and was porting it to new hardware. And initially it was a struggle. And then I got good at it. And I was like, oh man, I can see how all of this works. But then I realized I'm a mushroom. I'm in the dark. I have no idea what's going on in this company. And before, I used to talk to the guy that ran the division and speak to executives. And I'm like, what am I going to do? And then I got the job offer to go to Sequent. And that was like a technical sales role. And so I could do both. And so, and then when Sequent kind of had this revolutionary disruptive technology, but they kind of missed the technology cycle, and suddenly their price performance wasn't so good. So we had to get into the business of selling solutions. It's like, okay, you've got lots of cheap MIPS, lots of processing power, but what's this going to do to help my insurance business or register social security people for the UK government? And so I ended up starting a group that did architecture consulting and data warehousing design and strategy, because we couldn't sell cheap technology anymore. We had to kind of up it. And part of my job was to move. I was one of the people that was trying to move Sequent from being product-based to solution-based selling. And so I've had this back and forwards from being a worker bee writing software to pitching people at a senior level, to designing logical schemas, to trying to put together an architecture. And I think I'm happiest when I get to ping pong backwards and forwards to do that. And I think to do strategy well, you really need to drill down and test it, because there's a lot of snake oil. There's a lot of flim-flam artists. You have to know and believe and understand what the implications are of things. And I know we don't want to jump forward too quickly, but when I was first started at Wiliot, we had this revolutionary technology, computer the size of a postage stamp, battery-free, Bluetooth. But what are we going to use it for? And I joined, literally in the second quarter of the company's history, first person, very lucky. I joined first person outside of R&D, set up the field operations. But one of the first jobs was, who are we going to sell this to? Why would they want it? And it's actually pretty tricky. When you can do anything, what do you focus on, and where does it make sense? And it's 5 years now, and I think it's only really in this fifth year that the strategic implications of this, at one level, is a very simple technology. It's a sticker that can talk Bluetooth and sense and compute. What's it actually going to mean? And I think it took this embarrassingly long career that I've had to be able to join the dots. And, I believe this is going to be a dramatic transformation. The internet will explode to be 100 times bigger than it is. And it's going to change everything. It's going to change the way products are made, distributed, sold, reused in the circular economy, and ultimately recycled. But what I'm just amazed at myself, and I like to think out of the box. It's so easy to get your head down and just think, oh, this is just a sticker, or this is just a computer. And it takes knowing what it can and can't do at a fairly detailed technical level. And it takes going out and looking at the dynamics of the verticals that you're selling into to suddenly realize what's going on and what could happen.
Mm-hmm.
So
well, I
don't know whether that answers your question, but
it does. And I'm going to come back to part 2 in a second, but let me see if this word resonates a little bit with you. But one of the things that as you're talking about that, right, is you're able to tune into a side of you that has empathy. That empathy allows you to think outside of yourself, right? You know, where a lot of people who are hardcore coders, and again, nothing wrong with it, and I'm not saying they're not nice people, you know, that's not at all what I'm saying is, but they're very focused, right? They have a hard time kind of getting outside of where they're at. Can I relate to someone else? Can I empathize? In selling, if you're not empathetic, I don't know how you sell. If you're in marketing,
exactly right.
I don't know how you can exist in marketing without empathy.
Yes.
And even in product development. I mean, the core thing I've written a lot about the product development world and all the things I just mentioned is empathy, like the number one attribute. If you're a product developer and you have no empathy, you will never succeed because you're only going to be designing for yourself.
Yeah, that's true. And on one hand, people that don't have that, they can be very focused and incredibly productive. I mean, I when I joined Wiliot, I joked that they're an Israeli company, and I'm like, it's like going into deals with the commandos. And actually, it turns out they are commandos. A lot of them are actually commandos. But it takes like a super focus. But the flip side is you do need to have that seeing it from the other person's point of view and kind of gray view and using their vocabulary and trying to get inside what is it that makes them excited and scared if you're going to figure out how to sell something. But it can be very distracting as well, and you can become unfocused and you can also kind of become vulnerable. I was explaining to a journalist yesterday about our we have developers in Kiev, and I can't even think about it too much. I'm actually, you can probably see behind me, there's a picture of Kiev architecture where each of these meeting rooms is named after a city where we have an office. And I was tearing up. I just even thinking about our development team over there. And so it can be quite distracting as well. So I think you need to, if you're going to be effective, you kind of have to compartmentalize this and try and shift and say, okay, now's not the time to be empathetic. Now's the time to get on with it. And
well, you've got to be able to kind of tune that empathy a little bit. You know, it's not that you ever turn empathy on or off. It's just you deprioritize some of the inbound signals, right?
Yeah.
To use some of the technology that you're involved in, right? I'm depreffing some of the signal or attenuating the signal a little bit. All right, or I'm really reducing what I'm looking at in the packet stream, as it were, at times, right? Because I can't, otherwise it's too overload. If I sit there and, absolutely. I mean, I've got friends, if you're in technology, you probably know some people in the conflict, especially in the Ukraine, especially in Kiev, and it's horrible. It's absolutely horrific. And, and not to drift too far into that one, but I think one of the interesting things, politics, world geopolitics aside, though, I think maybe as a technologist, you can maybe reflect on this for a second, is for the first time ever, and I don't think people have really realized this, in my opinion, looking at this is the first war ever fought on social media.
Yeah, I think you're right.
We've never had a war that's ever been fought on where concurrently on Twitter, Instagram, Facebook, Elon Musk shows up. Playbook 101, you isolate the country, bomb the crap out of them, whatever, which is what Putin tried to do initially. But the minute he cut the internet, Musk shows up and says, here you go. I got SpaceX, boom, boom, boom. You're reconnected. And then you got Zelensky running around, posting everywhere. And you want to talk about creating empathy. It's like, in my opinion, I don't think anyone calculated for the impact social media was going to have. And it's completely shit. There's no room in the world to really allow Putin to maneuver at this point, in my opinion.
Yeah, and it's you just look at morale of troops, and they're fighting for a purpose, and they know the world is watching, and they also know what happens if they cede territory as well. So
right, yep. So anyway, so we'll come back. We'll come back to that because that's a whole other one. But but I also don't want to overlook the fact that as a technologist, and certainly someone who is at the vanguard of a lot of technical movements, one of the hardest things about bringing new technologies to market is timing it. is the market ready? Have I found the right fit? Product market fit. We always talk about that. But my classic example is Alexander Graham Bell, the inventor of so many things. But the phonograph, he had a top 10 list for uses of the phonograph, and not one of them was to play music.
Yeah, I know. I totally agree. I think I'd say in the Beacon Technologies book, we talk about the secret of good comedy is timing, and the secret of successful technology startups and large companies is timing as well. So we've all seen the great idea that's never actually dug its roots in. So so recognizing that is key. And I guess Qualcomm, getting back to your second question, has had some lucky breaks and some unlucky breaks that have turned out well. I mean, they've had some disasters that, like, they got into the TV business and built a whole TV channel and started using phone spectrum to do that. And it was amazing to see this kind of buying content, and they had smart people and they did it. And it was arguably not successful, let me put it politely. But then they sold the spectrum and made billions from their failure. So it was very instructive to be on the inside of that and see how they create ecosystems. CDMA, which is now core technology that's been part of 3G, 4G, 5G. They started off doing everything. They made base stations, they made handsets, they made the chips, and then they peeled it back and divested all those things, and they just focused on some core elements that then became part of a much bigger ecosystem. And they just, every time I was in Israel and traveling around seeing all the people on their phones, I'm like, every one of these phones has generated a small check for Qualcomm. They get money every time someone buys a phone, just from the intellectual property. And then if you were to tear that phone open to stamp on it and then kind of do the breakdown of it, you'd see a bunch of Qualcomm chips there as well. But all these other companies. That's
actually what I'm trying to get to is you're describing again, and I also want to point out here, it's a natural instinct, right? Where we look at, a lot of times we look kind of derisively at a company's failures, and we kind of like, it's a failure. Well, yeah, but those failures led to all the successes. So culturally, you were there during a period when Qualcomm was allowing, and I still think to this day, as a credit to them, culturally they allow for that kind of very creative, open. You almost have a blank, I don't say check, but you have a free reign to go do what you need to do. They'll try everything. And in fact, they're going to promote that you try everything. And then eventually, that through all that trial and error, they settle in on these multiple $1 trillion ideas. Amazon has a culture like that. Google has a culture like that. And because Qualcomm's kind of in the background for a lot of people, but is one of the most dominant mobile chip manufacturers ever, right? It's one of the most successful companies, but doesn't, I don't think, get a lot of credit for that. But you were there at a time when that was really robust. So I'm kind of trying to drill into that a little bit. Is what did you take out of that culturally? Because that, I can contrast that with so many companies that are very rigid, and we could name them. I can rattle them off. You've already named a bunch of them that just, I do it this way, and then it never changed. That inflexibility doomed them to what I call the La Brea tar pit of technology, right? And some of them are halfway into that La Brea tar pit already. Household names we know today, you just wouldn't normally think of it that way. But they don't maintain that culture of, and people talk about this all the time, culture of entrepreneurism, flexibility, whatever it is. I don't know what to call it, but there's something to be said where a company enables its employees to think creative, and literally truly fail, but not like fire anybody. Like, you actually learn from it, you adapt, you grow, and that success breeds success breeds success. So,
yeah, you can often have success and actually not learn as much as people think from it, and it kind of reinforces you, even engenders some arrogance that can be fatal. I think what Qualcomm did was they celebrated engineers. There was kind of a hierarchy. At the top of the hierarchy, there were engineers and lawyers. They had some of the best patent lawyers around. And then,
when you say lawyers, I get a little bit like, I'm not sure that's what I want, but okay.
I know. Lawyers. Creative lawyers, though.
Well, that's different.
Portfolio system for licensing Qualcomm's IP is
patent lawyers are a different breed. Yeah, patent lawyers are a different breed. Yeah. Sorry. So
I have huge respect for lawyers. I mean, it's good ones and bad ones, but some of the smartest people, and a lot of them actually think like programmers. They dissect and decompose problems, and so you wouldn't want to get on the wrong side of one. But So they celebrated that, and the joke goes, you have all these different functions, and somewhere at the bottom of that, there's the janitor and the business development people, and I was a business development person at Qualcomm, but they were great to their employees. It was a good culture, and a lot of it came from the Jacobs family, the founders. Erwin Jacobs founded the company. Paul Jacobs, his son, took over as CEO and chairman, and Paul thought laterally, and he grew up in the brew business, which was basically the binary runtime environment for wireless or something like that. So it's basically the APIs that the App Store business, this billion-dollar business, was built on. But he also saw health and television. The television thing didn't work out as it was intended to. It worked out financially. Healthcare business got spun off. Trucking business got spun off. So they were willing to place bets, big bets on these things. And they invested in Qualcomm Retail, which arguably wasn't super successful, but it created some of the best beacon technologies, all the beacons that were in the Apple stores that drove the welcome to the Apple Store message that occurred when you crossed the threshold, as opposed to when you drove into the car park, which is when you would get the welcome message before, because they were using geofencing. The beacon was not intended to be this revolutionary physical to digital technology. They just wanted a welcome message that actually gave the welcome message when you entered the store, which is one of the things that Bluetooth beacons are good for. So Qualcomm provided the hardware for that, and they provided the beacons that were at the Super Bowl and all sorts of great things. So it was a great learning experience. And then sometimes the best things to do are recognize this is a good business. We're going to carve it out and spin it out, which is what they did with the beacon business. And it became a company called Gimbal that went on to do its own thing. And when I was at IBM, they would just gone through this very traumatic downsizing. They'd gone from 500,000 people to 300,000 people. And it turned out to be one of the best things they ever did, not just for their balance sheet, but all those IBMers went off and became IBM VARs. And suddenly they became more efficient. And, this IBM expertise was diffused into a really potent partner ecosystem. And they, one of the things I learned there was partners are super important. It became impossible to sell anything direct to IBM. You had to do the order fulfillment through a partner. And that, built huge strength by having something that was better than a single strong company. It was, thousands of strong companies all working together.
Well, you've opened the door here, and I appreciate that. That's a good segue also into beacon technologies and kind of maybe a little bit more of the current stuff that you've been working on. But just as a primer here, and not to fly over it too fast, but at a very simplistic level, there are a handful of competing protocols that have all kind of played. I mean, everyone somewhat to an extent is probably used to Wi-Fi. Everyone thinks about that, right? 802.11, whatever. But then there's all these other little protocols that kind of people have been playing around. Bluetooth has been around for a long time. And as I said, its origination was just a simple, close proximity wireless protocol, right? If I remember correctly, a personal area network was how it was originally built, right? But then, since then, a lot of things have kind of glammed onto it, right? Because it's got a lot of use cases. So maybe just at a high level, if you don't mind, because you're obviously an acknowledged expert in the space, tell us a little bit about kind of your observations around how the protocols kind of all were competing a little bit. Bluetooth sort of, it's sort of won in a way in the personal space. I don't know much anything else that's everything building around that protocol. But then you have a particular use case in the beacon world, but there are plenty of other use cases that use Bluetooth, right? It's not just beacon and IoT kind of stuff. So maybe just a little primer for the audience.
Yeah, so Bluetooth, I think everyone is familiar with Bluetooth at some level. The brand equity of the Bluetooth brand is up there with Coca-Cola. It may not always be positive. You think of all the frustration getting your phone to pair with your car or whatever, but actually Bluetooth's success is down to a number of things. But one of them is it's actually a family of protocols. And Bluetooth was named after a Nordic king, Harald Bluetooth, who united these warring factions under one roof. And that's essentially how Bluetooth came to being. There were a bunch of technology giants, IBM and Toshiba and Intel, and they were all developing protocols to replace the cord that connected your keyboard to your computer and latterly your headphones to your iPod, but that wasn't envisaged originally. And so they developed a family of protocols, and there was ended up being Bluetooth Classic and Bluetooth Low Energy. People think of it as one thing, but actually there's remarkable levels of incompatibility at one time between those. Now it's all neatly dovetailed together. And Bluetooth is arguably one of the most successful wireless protocols in the world. There's tens of thousands of different kinds of devices, and the level of functionality, whether it's really high quality audio streaming, there's new functions that are around that, angle of arrival for centimeter level asset positioning, to connecting IoT devices. And the bit that changed indoor location and asset tracking is just a tiny fragment of a massive portfolio of technologies that is under Bluetooth, and it's called the Bluetooth advertising packet. And if you think about it, you've got a bunch of Bluetooth devices. We all have. How do they know about each other? How does your phone know that there's a printer that is nearby? How does your iPhone know that there's some earbuds or a watch nearby? And they know because they're broadcasting something called an advertising packet. And the way advertising packets work is a little bit like lighthouses, i.e. there's no connection. You're just blasting out an acknowledgement that I am here. And that's what a Bluetooth beacon is. It uses this discovery protocol that allows Bluetooth devices to know that there's another one nearby. But rather than kind of the preamble, the warm up to coupling and connecting, they're simply just doing the advertising and saying, I am asset 123. And I'm sitting here. And then people started figuring out, well, where is asset 123? Where is that Bluetooth tag or Bluetooth beacon? And they realized that it was a bit like that childish game where you say you're warmer, you're colder, you're warmer, you're colder. If you look at signal strength, and the signal gets stronger, you're probably getting closer to the beacon. So that, in technical terms, is called received signal strength. The RSSI is the acronym. And when the RSSI goes up, signal's stronger, it means you're closer. And so we started to use these tags, not just to say, well, there's a tag nearby, you can see the beacon, but you're getting closer or you're getting further away. And so you go from discovery of presence to proximity. Am I close? Am I far away? And once you have proximity, you can use that to get a sense of location. Like if there are 3 lighthouses or 4 lighthouses, I can only see 3, one's bright, one is faint. Then you start to get a sense of where I might be relative to those known positions, those known landmarks. And so that's the basis of the indoor location and the asset tracking, which are kind of two sides of the same coin. You look at reference points, you look at signal strength, and you figure out either where you are relative to these fixed points, or you have fixed readers and you start to figure out where the tags are that are attached to assets that you care about. And now, we've all got familiar with Bluetooth tagging because a number of us have Bluetooth tile tags on our key rings and so forth. So we kind of got used to the fact that that this is a useful thing, but that tagging technology has gone beyond keys and wallets to everything, and that's really what Wiliot, the company I work for now, is focused on, going from the Internet of expensive things, where you've got this big bulky battery beacon or tag on it, to everyday things, cardboard boxes, vaccine vials, packets of with vegetables and fruit in. All of these things can start to get tracked and connected, and the result, I believe, is going to be an explosion in the size of the internet. The internet is about to get 100 times bigger, and it's going to change a lot of things. It will be hugely disruptive, I think, mainly for the good. But it's something that it's a bit. I don't know if you remember the Y2K thing. The millennium bug. The fact that we all thought all our devices would stop working when the clocks rolled from December the 31st, 1999, to January the 1st on the year 2000, and I really see this explosion of the internet as being similar to that. It's something that's going to happen, and it can potentially be destructive for some if you're on the wrong side of it. But rather like all the companies that ended up renovating their IT infrastructure because they were worried it was going to stop working, this presents amazing opportunities, actually much bigger opportunities. Think if we can apply the power of the cloud and the power of the internet to things like packages of PPE masks. We've gone through a pandemic where we had shortages of things that shouldn't have been in short supply. It actually wasn't that there weren't enough PPE masks. It was they were in the wrong place and we didn't know where they were. Many hospitals actually had enough of the essentials they needed, but no one knew where they were because they were all in the dark. They were offline. And why wouldn't they be? We've gone through millennia where nothing's been connected to the internet, and then it was computers and then phones. But what we're about to get to in the future is where almost everything is connected. Every sock, every package has got intelligence, and it's going to be able to communicate. And that is just an incredible explosion that I think it sort of answers this question in my mind. It's like things are changing so fast. It's got to slow down. What can possibly cause this to accelerate? I think this is one of the things that's going to cause it to accelerate. We're going to have 2 orders of magnitude of growth in connectivity and intelligence, and there'll be new companies will spring into life. Old companies will disappear. Some old companies will figure out how to use this to even get bigger or more successful. But it's going to be a very, very interesting time.
I couldn't agree more. And as technologists, I mean, we've been blessed and cursed to be at the forefront of a lot of change that's good and bad. Comes with the pluses and the minuses. But let me kind of encapsulate just a little bit. So Bluetooth is a communication protocol at the end of the day, right?
Yes.
And beacon technologies or beacons are a use case of that communication protocol, because there's plenty of other tangentially related use cases of Bluetooth, right? Because I just want to kind of frame up, and you'll see where I'm going in a second. Is again, it's like Wi-Fi, like wireless, right? It's just a protocol. But there's a gazillion things I can do with it when I start letting my mind kind of get wrapped around it. And within Bluetooth, there's the beacon use case, or beacons, right? Which is about proximity and location and information going back. I'm not exchanging, video or, audio or anything like that. I'm focused on proximity. So if you were to encapsulate beacons as a use case, is it about the proximity location kind of computations?
Yeah. I think it can be about where you are. So indoor location, indoor navigation. How do I find my way around this hospital or shopping mall? Having a automatic check-in experience when you arrive in the doctor's surgery, so you're not queuing up. So it can be part of that. And that's about Bluetooth beacons. So beacons are stationary objects that give you an orientation, just like a lighthouse does.
Gotcha.
Tags are almost the opposite. It's the Bluetooth thing, the transmitter's moving around. So this is like putting the you're in a spy movie and you slap the tracker on the on the person's car and you're tracking it. So tags, just like luggage tags, baggage tags, they're moving around. So it's actually the same radio. It's just kind of configured differently, and the chip at the center of it is very often the same. They're very often made by a company called Nordic Semiconductor, but there's a bunch of ones that compete. And, that Nordic chip is the same, whether it's in a stationary beacon or a mobile tag, but what surrounds it tends to be different. Beacons are sometimes plugged into the wall. They get their power from a consistent source. Generally, if they've got batteries, then they're really big. Whereas tags, the idea is let's make this as cheap and as small as possible. So tags tend to be smaller. And where Wiliot ended up was going from being something that's a little bit bigger than a coin cell battery to something that's the size of a postage stamp, or actually even smaller in the case of we built a tag into a vaccine vial of COVID vaccine. So that is pretty small. So that's the range from beacons to tags, and it's all a subset of that much bigger wireless Bluetooth protocol that you were talking about.
Absolutely, and where I was going to jump in is because, again, big point of differentiation here. There's beacons, which are sort of the stationary things that people kind of navigate or use for their navigation purposes.
Yeah,
and then the tags themselves are often, beacons are active, whereas tags tend to be passive, right? More often than not, because if it's active, then all of a sudden I need electricity or power or something, and now I've got a different engineering problem I got to solve, right?
I think up until now both have been active, but Wiliot's technology is described as passive because it doesn't have a battery.
Right.
I mean, we can put batteries on them, but where the thing that differentiates us is it's it costs, rather than a Bluetooth beacon costing $10. This is like 10 cents. And one of the reasons why it's 10 cents is there's no battery. There's actually not even a printed circuit board. It's a chip that's glued to an antenna. And
that's where I was about to go. Is now all of a sudden you get into
passive.
How do I actually make this, right? Because, again, you start getting your creative juices going here, and I start thinking about power in a traditional passive device like this. And there's a lot of different sources of power, and we get stuck sometimes thinking electricity or batteries or something. Well, shit, I got kinetic energy, right? I mean, how many devices are running around today where I can just shake it and all of a sudden creating power, right? So if I've got something on a moving device, well, there's gravity or kinetic energy or solar or all sorts of interesting power sources. Exactly, right? Friction. I mean, whatever you want to look at. So I don't even think we've really scratched the surface on how to connect some of those things, or power, I should say, some of those things. But then I also think about where you're headed, which is we've miniaturized it, but simultaneously the materials with which we're building. You talked about a printed circuit board, but the materials with which that create the gates or the processor or whatever it is underneath there. We've also thought copper and other kind of materials, but can we get into organic style, materials that all of a sudden I've got a biodegradable tag?
Absolutely. You can absolutely do that. Yeah. I mean, that's one of the reasons why people like our tags is you don't have to put a battery hazardous sticker if you're shipping it through the post. That's like one small benefit of getting rid of the battery. I mean, you can get energy harvesting is not new. Solar energy is very, we're running around in cars sometimes that have been powered by solar panels on our roof. It is a massive source of high power. The problem is you need a solar cell, and even you can make them very small. We actually developed in our R&D labs a light harvester that can harvest light from the moon. But it needs to be exposed to the moon. You can't have it in a box that has got a bunch of other boxes piled up on it. Even then, it tends to be a little more expensive. If you start doing kinetic energy harvesting, which is very often in light switches, there's some great implementations of that. That's great, but then the mechanics make it bigger and bulkier and more expensive. So energy harvesting from radio waves, it turns out, is the hardest on that spectrum of energy. There's probably a few other things, but in terms of mainstream energy harvesting from radio waves is one of the hardest things by about 3 orders of magnitude in terms of, you compare the energy that you get from a stray Bluetooth signal, which is what we harvest energy from, to harvesting from sunlight. And it's just many, many orders of magnitude less power. So, I mean, the benefits of having energy harvesting from radio waves are incredibly low cost. You don't need to, it can be super simple, it can be tiny, and it doesn't need to be on the surface. It can have things piled on top of it. And so much more versatile, flexible, economic, and scalable. The problem is it's just 1,000 times harder to do it because A, how do you capture that very weak signal? B, once you've kept it, how do you stop it evaporating? There's circuits have this phenomenon called leakage. So I've harvested all this energy. How do I do something with it before it disappears through the hole in the bucket, which is, the way these electronics work? And then even if I manage to make the hole in the bucket tiny and I capture the energy, I still don't have very much energy because this is like from a radio wave. So how do I do anything useful with the tiny amount of energy that I have? And those are the core technical problems that the geniuses that I bumped into at a conference on RFID have been able to solve. They're some of the best semiconductor engineers in the world. The previous company to Wiliot was one called Wilocity. Wilocity pioneered millimeter wave, which is, in short, one of the things that makes 5G faster than 4G. And Qualcomm bought them. They bought them, and it was a great exit. And so they kind of did that sale of a technology that was very high performance, kind of premium chip cost, to, well, okay, we've got done fast and relatively expensive. What about going the other end of that spectrum? We could democratize IoT. We could take it from being this expensive technology on expensive things. What if we made it disposable and recyclable and tiny and low cost? So we could democratize the Internet of Things and have the Internet of Everyday Things. And so, when I actually found them at the RFID Journal Live conference, I was teaching a course on Bluetooth beacons. It had been a harrowing day because I was very nervous that teaching about Bluetooth at an RFID conference, either no one's going to show up or they're going to show up and they're going to lynch me because, Bluetooth and RFID, competing technologies. And actually, I found that neither of those things happened, although the room was empty when I got there. I was setting up my lecture materials, and there were like 3 people sitting, looking at me warily. And then the hand on the clock kind of went to the top of the hour, and suddenly this room filled up with almost 100 people, standing room only. And it was a full-on day of audience interaction and learning about some of the stuff we've just been talking about, getting into a bit more detail. And then at the end of it, this Israeli guy came up to me and he said, I am CEO of the startup. We're just a few weeks in, and we're going to create a passive Bluetooth radio. Would you like to do some consulting for us? And I kind of looked at him and I'm like, I have no idea what you're talking about. I've just read the book and given a 1-day training course. And, the words passive Bluetooth have never, come out of my mouth. And I don't know what you're talking about. So I was very tired. And I politely, as I could, said, no, I don't think I can help you. Like, obviously a really smart person. So I can't help. Right. And he said, well, what about let's just chat, have a coffee? And so I said, okay, all right. So we'll meet tomorrow at Starbucks and we'll talk about it some more. And I didn't think about it again until I was driving home from wherever it was, Palm Springs, I think it was. And I'm like, oh, God, I forgot about that meeting. And I'm like phoning up and I'm like super apologetic. I'm sorry. I should be in Starbucks with you. And basically I said, I'll do, whatever you want me to do, I'll do it. I just felt mortified that I'd stood up this really nice guy who's obviously a genius. And so I then start this consulting project. And the project was, what are we going to do with passive Bluetooth and what can it be used for and what can it not be used for? And I'm like, started to create a huge spreadsheet. And then they basically said, oh, we're looking for someone to set up our US operations, and you seem like you might be useful. And I went from being very standoffish and British to being undignified and like, yes, I'll do it. This is amazing. And I joined up as employee number 13. The first one outside of Israel. And my first job actually was to, beyond the, what are we going to do with this, was they'd already raised $10 million in their first month, just based on their resume. And but Qualcomm and Merck, the German pharmaceutical company, wanted to invest. And my job was to create the business plan because Qualcomm doesn't just write you a check. They're like, yeah, Tal, Alon, you're brilliant, the three founders, but show me a business plan. And I'm like, well, that shouldn't be too hard. You raised $10 million. Give me the spreadsheet that you used to raise the first $10 million, and I'll, maybe add a few extra columns to it and update the assumptions, and we'll be good to go. And Tal, the CEO, said, well, I don't think this is going to be very helpful, but I'll send it to you. And he sent me the world's smallest spreadsheet. It was like 4 rows, 5 columns. And that's what the early investors, who were all financial investors, part of the Israeli high-tech ecosystem, they knew these guys. They heard the 1 trillion democratizing IoT pitch, and they were just in based on that. But that wasn't enough for Qualcomm. So I produced a huge spreadsheet with lots of different variables in it. And that was really the start of my job working at Wiliot.
Well, let me, and again, as I told you at the beginning of this conversation, I look at the clock here, an hour has flown by, and I feel like I got about 10 more hours at a minimum, if not days or weeks, where I could dive into a lot of detail. So I'm gonna close down a little bit, just to be mindful of your time and keep it to an hour, or a little bit over an hour. Is now, and we didn't even get to this, but you are sitting at the vanguard again of the adoption of a particular type of technology which will connect physical devices. And this is up and down the stack, from shoelaces to parts for SpaceX, from cars to airplanes to my coffee cup. I mean, whatever it is. So a couple things there, and it's weird to say this too, but I again agree. We're sort of at the early stages still of this. RFID was kind of playing around there, and now you guys are kind of, there's some convergence happening. What's the best of RFID? What's the best of Bluetooth beacon? How does that all come together to create this mapping that we're all looking for? Because the problem doesn't change. The problem is we want to connect all the devices. How do you do that? So what do you see over the next couple of years? Because that's, for me, in my entire pursuit of supply chain, I have always told everybody, no supply chain will be figured out until we know where all the assets are, down to the discrete level. Yep. And to do that, we need something like a beacon technology attached to everything. And people always ask, well, how small does that go? Do you go down to the screws? I'm like, well, maybe not yet, but eventually materials will come around that we can do that, right? We're just not there yet. That's what I was asking about the organic stuff and some of the miniaturization that's going on. But what do you see today as sort of the big, how does whether it's Wiliot or beacon, how is that getting introduced? You guys are playing, I think, in pharmaceuticals right now, but where are you seeing a lot of these sort of early adoption? What verticals, what spaces, where you guys
Well, playing? It's interesting. We've got this bookends problem again. It's like the big picture is just huge. And ultimately, there's so many very important problems that this can have a material impact on: climate change, reducing our carbon footprint, food safety, drug safety, traceability. Are we really going to throw away every leaf of spinach in the whole of the United States the next time someone gets sick? I mean, that is like we're in 19th century behavior in the 21st century. So, and the FDA has been banging the drum on this. And I have to say, Wiliot won the FDA's traceability challenge. I'm going to, it's an advert for that. But more importantly, companies that make food need to act now and start doing something called serialization. And there's other companies in other industries that are doing it. The forward-thinking Ralph Lauren, a couple of years ago, announced every single Ralph Lauren product will not just have a SKU, but it'll have a serial number, a bit like the VIN number in your phone. Your car. It'll have a unique ID, a digital twin, a digital passport. And that's got nothing to do with the beacon technology. That's applications, data, but it impacts how you manufacture. You need to issue the passports, when the birth certificates, when these products come into life. So companies need to get on with that. And why would you do that? Well, you do that because once you have that, then you go from having a supply chain that's in the dark, where you kind of wave goodbye. It's a bit like your kids, they're 18 and you're like, I'll see you in a few years' time when the laundry gets so dirty you have to come back to use our washing machine. That's what we're doing. Most companies are doing that way. Okay, maybe there's some EDI, you've got the odd tracker on the truck, but essentially you have no idea where your stuff is. And as a result, we're making almost twice as much material. We're employing double the capital in our supply chains. We think they're lean, but they're not lean. They're bloated. It's archaic because we have no flipping idea where the stuff is. So how do you deal with that lack of visibility in the supply chain? You just make more stuff and you push it through the channels and you hope that you don't run out. But you don't know. The future that I see is a move from supply chains to demand chains. And that the demand chain is really that's the model that fixes a lot of this, where you have demand signals. You can see consumption in real time, sales events occurring in your wholesale retail channels. So you make jeans, you should know every time Macy's sells one of your pairs of jeans. And then actually, if we do this properly and we provide value to consumers and do the right things in terms of privacy, we should actually know when people are wearing those things. Did they bought the jeans? Did they ever wear them? Did they wear them once and not wear them at all? Is their wardrobe full of stuff that they really don't like and they only really like about a quarter of it? If that's the case, why don't we buy that stuff back? Give it to someone else that does want it. And then maybe we can make better quality stuff, stuff that's durable, not this fast fashion that's polluting the water. And we can all wear nice stuff that fits us. I mean, that's if you start giving a unique serial number to every item, and then you put a tag in it that can talk to the phone and the smart speaker and so forth, then you can start to actually move to a SaaS model for clothing, a SaaS model for vegetables. It's so what do I mean by that? I mean a subscription model where the apparel company becomes the Netflix of apparel. What does Netflix of apparel mean? That means I have a direct relationship with the people that are using my product. I know what they like and what they don't like. And once they've finished with it, I take it back, just like we used to with the DVDs that we rented. So that model can apply to everything from pharmaceuticals to food. You could be the Netflix of herbs and spices. You could know, rather than having an Amazon dash button that you press, you could have a jar of parsley and a jar of cinnamon. And we can take those 3 jars of garlic that are all out of date, and we can make sure that you have 1 jar that hasn't expired. If you have connected packaging for all of these consumables, we can reduce waste. 30 to 40% of food is wasted even before it gets to our plate. That shouldn't be happening. And it's happening because stuff sits in the sun. It's waiting where people don't know where it is. If you just So where do we start? So that's the nirvana. That's the far bookend. Where we can start today is let's put tags on plastic crates and pallets and rolling cages. And these are the arteries for the supply chain. If we can get our arteries and the vascular system in shape, if we can instrument it and know where the crates are, then we can see, oh, that crate's been sitting in the sun, or these crates with tomatoes, they've been sitting at the back of that packing shed for a day. They should have gone out in an hour. If we can stop that, then you've just added a day of shelf life. That means that it looks better in the store. You're more likely to sell it. It's going to last longer in someone's fridge. You then start tracking it in the fridge. Then you can remind people to use the lettuce that's been sitting there for 3 days. And that's actually already starting to happen. We have a partner called Sato in Japan that have been working with the Japanese government, and they've been putting tags on the packaging that goes on vegetables and fruit in the fridges in Tokyo. And so they know when there's stuff that needs to be used up, and they can guide people and look at the rest of the waste. That after you've wasted the 30 or 40%, you're wasting probably a significant proportion of what goes into people's fridges. So that's the future that I see. I see better food safety, better drug safety, much less wasted resources. All of the CO2 emissions and methane from that rotting food, all of the dye that goes into the rivers. We can actually save the planet, but also help the companies that adopt this make money. It's not an act of philanthropy. It's pure self-interest.
Correct. So I'm gonna put a cork in it there, because honestly, hour and 10, hour and 15 into it, I literally want to sit on a stage with you and talk about this, because everything you're saying, I would come from the other side, which is the supply chain requirements, the supply chain needs, the assets. I've got an entire infographic made by a guy out of the Hague, I think, Mark DeWitt, Circle Economy, that I use, that depicts the 108 gigatons of stuff that we use and how do we actually track all that. Half of that's food, half of that's materials. So much here, but the answer to it all, as we all know, is 42. So
exactly. Episode 42, historic episode. 42, I really enjoyed it.
The answer 42 has been awesome, Steve. I knew it was going to be a pleasure, but thank you so much for spending time with us today. I'd love to have you back, and I'd love to continue the conversations in a lot of different ways, because there's a lot of stuff here that's
Richard, it's been an absolute pleasure. Thanks so much. Great job, and I really enjoyed it too.
Thank you. Thank you very much.
Thanks for listening. If you have any comments about this episode or topics on supply chain you'd like us to cover, you can reach us at supplychainnext@requis.com. And while you're at it, check out the Requis platform at supplychain.requis.com. Requis allows you to manage the full asset lifecycle in the cloud while collaborating with your entire value network to buy, manage, and sell your assets. Find out more at requis.com.